So we're going to continue with doing the sum, but it's going to look a little bit different. This is called summation notation. Summation means you're finding the sum. You're going to be adding them all up and finding the total, or finding the sum. Notation is how something is written. So you'll know something is summation notation because of this letter, sigma. Sigma is a Greek letter in the alphabet. You'll notice a lot as you go on, like when you dealt with theta. Theta is like the letter T in Greek. A lot of math was created, found, I don't know the right word, by Greek mathematicians. So they're like, hey, if I'm going to pick a letter, I'm going to pick a Greek letter. Okay. Now, when I do summation notation, you always start with the number here, and this is the ending number. So if I wanted to find the sum of the first 10 numbers, this would be 1, and this would be 10. If I wanted to find the third number in the sequence to the 11th term in the sequence, the 3 would be here, and the 11 would be here. And then we've got to know what type of sequence it is. So the formula, or the rule, is what goes right there. So if you look right here, they want you to find the sum of the second term. So if you have the first term, the second term, the third term, and the fourth term, they want you to add the second term through the fourth term, and then here's the formula to make it happen. So I would go 7 times 2 is 14, minus 1 is 13, plus 7 times 3 is 21, minus 1 is 20, plus 7 times 4 is 28, 27. Add those up, and the answer would be 33, 53, 60. Okay. This is saying I want the sum of the first 5 numbers. I want the first term, the second term, the third term, the fourth, and the fifth. Add up all of those and tell me the total. And that's what we're going to be doing. Okay. So I also want to show you here, it's kind of hard to read, sorry about that. But I want you to see these all say n equals 1, n equals 1, n equals 1, n equals 1, n. Now there's certain formulas where if you just have a c, which is called a constant, which it's kind of hard to see, but that's the word constant, there's this formula that says if you're adding the sum of the first 50 numbers, and this is 6, you just multiply n times c. So n times c, let me make that darker. This is saying, okay, if you have the parent function for a line, we'll call that x. You use the formula n times n plus 1 over 2. This is saying if you have a quadratic, but just x squared, you use the formula n plus 1, 2n plus 1 over 6. And this one is saying a cubic, and I actually don't care about a cubic. Okay, so we're just going to do constant, linear, and quadratic. So what is this one? Well, it's a constant. And some of you go, what? Well, let me explain what they're asking you to do. They're asking you to find the sum of the first 47 numbers. So the first number plus the second plus the third plus the fourth plus the fifth, dot, 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 all the way to 47. Well, what is the first number? First number is 6, because you can't plug anything in. Well, what's the second number? 6. What's the third number? 6. Well, that's your constant. It does not change. That's what constant means. It doesn't change. So if I was to do the 6 47 times, I'm really just going 47 times 6, which is 282. So the sum of the first 47 numbers is 282. Okay? Let's go to the next one. And that was that formula right here. Let's go to this one. Oh, this is a line. This is the parent function for the line. This is saying you add the first and the second, the third, the fourth, all the way to the 15th number, and you will get the total. So what is the first number? 1. What is the second number? If you plug in 2, 2, 3. So you're really going 1 plus 2 plus 3 plus 4 all the way to 15. This is kind of like the first, when we found the sum of the first 100 numbers, but we never found it. This is the formula. It's saying, okay, your n represents how many numbers you're using. So I'm going to go 15 times 15 plus 1 over 2. 15 plus 1 is 16, divided by 2 is 8. 15 times 8 is 30 times 4, which is 120. So the sum of the first 15 numbers in this sequence or series is 120. Now, what they're also saying is, okay, this time it's a quadratic. So this time when I do the sum, 1 plus 2 plus 3, 4, all the way to ... 10, you would go 1 squared, 1, 2 squared, 4, 3 squared, 9, ... all the way to 100 because that's 10 squared. The formula says, hey, take that 10, plug it in here, and you can get the total. So I would go 10 times 10 plus 1 times 2 times 10 plus 1 all over 6. Okay? 10 plus 1 is 11. This is 21. I'm going to simplify because I can't help myself. 5 and 3. And then 3 goes into 21 7 times. And then 7 times 5 is 35 times 11 is 385. So the sum of the first 10 numbers is 385. And I got to tell you, the reason I knew that is anytime you multiply anything times 11, if you add these two numbers, you get 8. Put that in the center. That's your total. If it was 339, what's 3 plus 9? 12. Carry the 1. 429. Just a side little thing. Okay. Now down here, they want you to find the sum. Well, it isn't a constant. It isn't a parent linear. It isn't a parent quadratic. So I have no choice. I have to list them out. So I'm going to go 4, 5, 6, 7. You know I like things in little boxes. And I'm going to take the fourth term, and I'm going to plug it in. And I'm going to go 4 times 4 squared, which is 64. And then I'm going to go 4 times 5 squared, 25, which is 100. And I'm going to go 4 times 6 squared, 36, 72, 144. I could be adding these wrong. I'm sorry. I'm just trying to go fast. 7 squared, 198. 98. I'm not getting smart right now. I think it's 196, yeah. And then I want you to take all of those numbers and add them all up. Okay. So I'm going to go 64 plus 100 plus 144 plus 196, and I get 504. I can't say the sum of the first 4 numbers because it's the 4th number through the 7th number. So I don't want the 1st, the 2nd, and 3rd. I want the 4th plus the 5th plus the 6th plus the 7th. That's what I want. Okay. This one's saying, hey, this time start with a 0 term and go all the way to the 4th term. So I plug in all of these into K. 2 to the 0, 2 to the 1st, 2 squared, 2 cubed, 2 to the 4th. Anything to the 0 power, 1, 2. This should be no problem. 8, and then 16. What should I do? If it's summation notation, I'm adding them up. So 3, 7, 15, 31. And I can't say the sum of the first 4 numbers, or even 5 numbers, because it's not the first 5 numbers. It's 0 through 4. So all you can say is the sum is 31. All right, last one on the page. 1, 2, 3, 4, 5. This time I'm going to take these, plug it in here. And hopefully you're just doing this yourself. You're not just copying everything down because honestly, it's just better for your brain. And you don't need to copy it down. You know how to multiply. You know how to add. Okay, so let's see. That's 5, and that's 2, 5 over 2. 6, 8 over 3, 8 thirds. 11 over 4. Well, I notice a pattern. Oh, do you guys notice the patterns happening? Let's just double triple, but I think it's plus 3, and on the bottom it's plus 1. Let's see if that works. 14 over 5. Ah, it does. So that means I just go plus 3, and now I got to add those up, and I get a number, okay? You get the idea. But this time, I can say I'm finding the sum of the first 5 numbers because I'm starting with the first number. So notice the difference. Okay, let's go to here. What time are we at right now? I think I'm going to wait till the next video.